welcome. Many of you know me, but I'm Chris Gorman. I work at the Center for Educational Innovation, and my role focuses on supporting teaching and learning in STEM disciplines. I know many of you because I've been working in science and engineering with science and engineering folks for 7 years now, and both at the Duluth campus and on the Twin Cities campus. And we've got folks from both joining us, which I think is a really great opportunity too for some synergy between the two campuses. So today's discussion is part of a series of discussions designed to bring folks together, teaching courses with experiential components. And then today's discussion is the one focused on engineering labs. And then I will be recording the session and consolidating notes, both from what's verbally presented and then also what's exchanged in the chat. And we're doing this so that you all have notes that you could come back to if there are links and you miss them or you didn't download the chat or whatever at the end. We can make sure that you've got them. And then also so that they can be shared broadly with the university community as we go through an unknown next few months. And I'm gonna just at the outset say thank you to Barbara Beers and JD Walker, who are helping me to monitor the chat and take notes. So if I miss anything, then they'll help me out. Let's see here. So based on our registrations, we successfully only have engineers in the room. So we did good, but you're all teaching courses in engineering on the Twin Cities and Duluth campuses. Most of you are not teaching this summer, although we have 2 or 3 of you who are. And so we want to be particularly helpful to those couple of folks. And then what I'd love for you to do is feel free to introduce yourself in the chat so we know maybe that course or title of the labs that you're teaching and what department you're from. It'd be great to help connect those with different departments or campuses who might be teaching similar things. So go ahead in the chat and just type in a little bit about yourself. And if you can spell out your acronyms, since they're not the same on the 2 campuses, that would be really great. Sorry, I'm going to be great. Okay. And as you're typing those in, go ahead and I'm going to tell you about what our goals are today. Our goals are to share ideas, things that have worked well this semester. One of the things that's interesting about engineering is that we don't have any folks who have designed engineering labs to be online. So we won't have that particular experience, but what I want to do in this discussion is leverage the experience that you all have been having doing labs online this semester and talk about what worked, what challenges arise, what are you concerned about, thinking about the potential of an entire semester being online. And so the idea is to share ideas, those things that worked, and then problem solve, especially for those couple of you who are teaching this summer. So if you have a summer course where you're knee deep in planning, but you're running into some trouble or just want to bounce an idea or see if something sounds like a good idea or a bad idea with this group, that would be a great opportunity as well. So the Zoom tools we're going to be using today, I think we're all logged in now. There's 30 of us. That's a somewhat manageable group, but I will, so ask your questions either in the chat or just raise your hand to talk. I think that the verbal exchange could be really helpful here. I'm just going to play a little bit of traffic control. And so if you could raise your hand, that's helpful. Otherwise, we can try just unmuting, but I think we're right at the edge of where that'll work well. So, and you'll find the raise hand button in the participants panel. At the very bottom, there's a set of reactions, and one of those looks like a hand, and you can raise that hand, and then you pop to the top of my list so I can see you. Awesome. Okay, and then without further ado, what I want to do first is talk about some things that worked well this semester and just share some ideas. And if you don't mind, I'm going to just call on Jim Vandeven to get us started.
Hi, Chris.
Hey.
So are you looking for input on the teaching lab that I've been doing this semester?
Yeah, why don't you get us started with something that worked well? When I talked with you, you felt really good about how that was going. And so I just wanted to just start with a bright spot and a good story, and then we can hear a few other good stories, and then we can switch to some challenges.
Yeah, sounds good. So I've been teaching a 4,000 level class that is it's a lab-based class where students meet 2 hours twice a week in lab and then have a 2-hour lecture once a week with me. And so basically I had to come up with virtual labs for this class, and I ended up using Simscape in MATLAB Simscape, and it ended up working really well. This is a fluid power controls lab, so I ended up using their hydraulics plugin and really designed a lot of the same labs that I would have had in class in the virtual environment. And I was amazed how I was able to really take a lot of the same exercises I would have done in the physical lab into the virtual lab. So I was very happy with that. Felt that worked quite well. And then just used Zoom quite a bit. The classroom part of the course I had already flipped, and so I had a large number of video lectures that students were already watching ahead of time. And then in Zoom, I was using breakout groups and a whole variety of kind of the polls and things like that to try to make it as interactive as possible. So I was doing very similar activities that I would have otherwise done in the classroom, where I've had students work in groups and report back and things like that. And, it took a little while for the students to be comfortable engaging in that, but they started then sharing their videos and then sharing their screens and working from that. I was really impressed with how the students stepped up really it became a lot more interactive than I expected it to be. So I was happy with that.
Any questions or thoughts or reactions to Jim's?
Hi, Jim. This is Emmanuel. Is this something that you started this semester, or was it something you were doing before?
Yeah, good question. I had previously flipped the course, so I had already pre-recorded all these video lectures that I would usually use for my 2-hour, on-campus course, and then I had prepared kind of the activities I would usually run in the classroom. But I hadn't prepared any of the lab-based pieces of it. So normally they're in a lab working with physical equipment, and so all of that I had to prepare in the virtual environment. So that was the new piece for me. And so I really just tried to transport as much of it that I would normally do in person and on physical equipment to the virtual world.
What about teams? I assume that had they been there in person, they would have worked together in teams. You do a virtual lab in teams effectively?
Yes, so the students would, the normal way it was working is students were meeting in groups of 6 with the TAs in lab, and then they'd be 2 groups of 3 is how I would do it. And so I still had the TAs keep the same lab hours, and so the students would still log in with the student or with the TAs in Zoom and basically go through the lab, ask questions as they were working on the virtual lab, and run it very similar to what they otherwise would. So there was still quite a bit of contact with the TAs in the smaller teams. And so usually the lab sessions, the TAs broke them up into breakout rooms, into 2 different breakout rooms. So 2 groups of 3 working simultaneously, and then the students would call them in with questions, or they just drop in on those breakout groups.
Anybody else use groups in their labs this semester, successfully or not?
Yes, this is Imad Abdini. Hi. We have used groups. In fact, we have a sophomore class, EE 2015. This is the 2nd time we run it, and we actually find it even more effective with the new situation that we're in. In a way, we were able to engage the students more because it's almost always face-to-face. We kept every single session of the lab. We were lucky to have already started making video resources for the lab even before. And so all the procedures were recorded for the students, but then what we were able to do is to engage the students by data processing. For example, they read measurements directly from a screen of an oscilloscope before. The specific scope that we use actually has data that can be imported into MATLAB where the student can do further processing. So it actually added another dimension to what we do, and the reports are richer now and with more substance. So it something came out of necessity, but allowed us to actually help enrich the student experience in terms of data processing, which is something that was kind of missing in the fall. semester when we offered the course the first time. We used the same capabilities, breakout rooms for the teams. So every team that before spring break kept their membership, and when they go to the lab, so every lab session was live on Zoom with the TAs, and sometimes I would join. Also, I managed to get the physical lab to my house, so I actually recorded the procedure for the students, and we shared with them the data from these experiments. Going forward, we actually like to design the same approach, but actually increase the number of variations and data measurements and so on, so that different student groups may get different measurements if we have to do this in future semesters.
Yeah, this is something that's come up in some of the other discussions with science folks, is what kind of data to provide to students, but I'm going to go to Dave as well.
Yeah. Sure. So I wanted to talk a little bit about group projects. So that's a lot of where the working together happens. And we found that there was a need for students to have like check-in sessions with faculty more so than ever. The ability to be online actually seemed to increase the need for face-to-face time. And so we came up with questionnaires or check-in points where students would update us on how they were doing in their project. And that seemed to help quite a lot, keep students on track and identify students who are falling behind. And the other thing that I thought that was pretty critical was we had several students that ended up in quarantine or in other time zones because of transit home in the middle of the semester. And so we made most of the group projects at least semi-optional in some way, so that students that were removed or out of contact with other people could still, participate at some level. And so they'd have an individual project. And a lot of this was enabled by the fact that a lot of our labs have full kits of equipment that students take home and keep with them. So they're part of our lab fees. They get to keep the microcontroller and the programmers and all that. And that enabled them to work on their own in any environment they may be in, and helped a lot. So I think those are some key points.
Dave, can you say a little bit more about those check-ins? So what were the format and what kind of questions did they have in them? Were they like a Google form or?
Yep, exactly. So there was like a Google Doc with the /copy on the end of the URL, and that allows them when they go to that document to get a copy of it, and they can fill it in, save it as a PDF, and submit it back to Canvas. And so what we had was a couple of different formats of that. One where they just filled it out, turned it in, and we graded it. Another one where they filled it out, reviewed it with a TA, annotated it as they went through, and then turned it into Canvas as a record of kind of where they were and where they're at. And so they were just, they're just really prompts to get them to talk about the important pieces of the project that they needed to be on task or on time in order to complete the entire project before the end of the semester.
Nice.
Yeah.
So can you explain the kit? You said the students have their own equipment that they took home with them?
Correct.
So Dave teaches electrical engineering, which might be an important piece of this.
Yes,
Okay.
thank you.
So we're talking circuit kits.
Yeah.
Right. So we have microcontrollers, we have transistors, we have resistors, breadboards.
Okay. Okay.
And that is highly portable. And we've just chosen over the last few years to kind of include more and more in that kit so that they're mostly or entirely self-contained. And that's really been an enabling element in our lab curriculum. So.
On the other hand, had they been in person, do they bring their kits to a lab space, or do they still work with at-home equipment at home?
Nope, they bring them to lab with them so that they get face-to-face and hands-on debugging time with a TA, which is an interesting actually side point that I didn't mention was it definitely takes more time to debug a circuit over a video with holding it up in front of the camera like this, right, than it does in person where you can move your head around and see around objects. So it's a little bit more work for sure, but it was doable.
Do others have successes or challenges that arose this semester, things that worked well about their labs going online, things that they would love to, questions that they'd like to throw to the group?
I have a question. This is Stefano Gonella. It seems it's related to what you were asking. It seems to me that all these virtuous examples of success so far have been regarding really non-physical labs, like electrical engineering labs. Are there any success stories that pertain to, say, physical labs? Anybody that's been particularly successful or creative other than simply filming the whole lab and then sending the data to the students, which in some sense denies the whole point of a lab? It becomes just a data processing assignment.
Yeah, I'd like to address that if I can. This is Ahmad Bini again. So actually, yes, this is the only option that we have right now. So David mentioned the kits, and we have kits in our lab as well. But unfortunately, the students do not have the rest of the instrumentation that they can, make measurements on their kits, only limited measurements with the kit. So that was the only option. But it is a physical lab that in the future, going forward, of course, we didn't know that we're going to be unable to use the physical, the kit that the student has, at least in our case. But going forward, we can extend the student measurement capability so that they can do some of these measurements with their own kits at home. That will be a small step from what we have done. Now, the lab, some of the equipment in the lab are much more expensive than the student can afford. So we can give them something that's low cost. I think this can, what I'm trying to say is that what we were able to do this semester can be extended to allow the student to do some physical measurements. Maybe not everything that you planned for them in the lab, the physical lab, but they still can have that option with the kits that we use the same system where, for example, the students have their electronic component and so on. What they're missing for them is that they don't have some measurements. Unfortunately, nowadays, we have very low cost oscilloscopes and things like that that the students can also acquire, just like a textbook, and that problem will be solved. But it was gratifying that we were able to engage the students. To me, that's the most important thing. We never have a drop of attendance. The students were engaged, they asked questions, they used the full 2 hours of the lab, which is to me very gratifying. That was what I was trying to say.
Stefano, what's your, which department or field or course?
Yeah, that would be, I can put up my video on for a second. That would be civil engineering. So that's one scale more complex to deploy than what we've been talking about. So we are going to have to scramble a lot more.
Right. So they can't build, big concrete things and then test whether or not they're going to take the weight, right?
That's right. There are maybe a couple of pieces of equipment or machines that students converge to and they use. And so that's not going to be portable. So I was trying to figure out if anybody that worked at that kind of scale and had some kind of way of somehow transporting the experience home to the students, even if, of course, they cannot have the machines.
Yeah. Jim, do you mind saying a little bit more about the simulations you used? Because this was actually, students don't normally do simulations in your lab, but all of a sudden went from doing physical levers and stuff into a simulation.
Yeah, that's exactly right. So, normally they're working on hydraulic circuits, which, are built up of valves and pumps and things like that, and also then doing controls of these. So I just built basically the same circuits in the virtual environment in Simscape, which then has built on top of what's called Simscape Fluids, which basically just has all of these components you can drag and drop, create it like a Simulink block diagram. And then it will solve all the differential equations internally. And so really, I built the same physical systems that they would otherwise see. And I created kind of a foundation of here's the physical system, but then let them expand from that. So for example, I would build a position control system for a hydraulic actuator. And then they had to take and add sensors to it to measure the position, then use that position to close the loop and build a proportional controller to do position control on that actuator. So they really were doing very similar things to what they would do in the lab, where they were connecting either sensor data and comparing that to the reference signal and using that to close the loop, or in some cases actually taking physical components or virtual components and connecting, this valve to this actuator to this pump. So I didn't give them any data. They generated all of their own data from the Simscape environment. And so I felt it was very analogous to what they were doing in class. And, you know, I didn't have any videos of what they would actually have worked in the physical lab, and I wish I did. But I thought that this was a pretty good replacement for it.
Anybody else who was able to replace their physical labs with, of course, this semester with getting what, 5 days notice?
Yeah, if I may join Stefano, I'm in mechanical engineering, and the labs we do are very large scales, making things like casting or melting metals or building composite panels or tensile testing. So we're dealing with huge equipments that they were very difficult to do what electrical doing small portable kits can do. So what we were trying, or what we tried to do, was basically using the TAs to record the experiments that the students would have done themselves. Normally, the students would do these experiments as a team in the lab, get their measurements, and do analysis. But this semester, we were not able to do that. So what we did was have the TAs run the experiments, record the video, provide the data, so the students watch the video of how to cast metal and do hardness or tensile tests, and then provide them what the data should be, and ask them to analyze and write reports. So that was all we could do. I was hoping, like Stefano was mentioning, if there is any other way to make it a better experience, rather than, just, running it in a video and they're watching video and giving them data.
Yeah.
If I can follow up, I was thinking, I haven't taught the class with lab yet. There would be a fall endeavor. And exactly like Emmanuel said, it's going to be most likely just a matter of filming and transmitting the information, which is sort of depriving the students of the real lab experience. What I was thinking about was perhaps to involve them, since that doesn't seem to be fixable, to involve the students more in the design of the experiment. For example, typically we we have protocols. There's like a lab manual, they learn about it, and then they implement it when they join the lab in teams. Maybe before sharing that, asking them as an assignment to think how they would design and test an experiment if there were no protocols. So they have to at least picture the scenario in their mind, be a bit more involved. And then of course, the actual protocol will be shared, and then the experience will be shared virtually, like Emmanuel was saying. But at least they would be more aware of, I guess, the thought process that historically went into the creation of those lab protocols.
Well, and Stefano, that's an interesting design for a lab, because as long as you weren't probably having more than one person at a time going into the lab, they could design labs which then someone could go in and execute the procedure and then find out what happens. And there could be a real engagement there where, where you could, I think Mike successfully did this semester, but applied for some exception status, so you can go into the lab if you need to take videos. I think Mike successfully did that. And so even if this continues, that you could do that kind of setup of design it and then even do it and then get data. A lot of folks who are doing science labs take advantage of the at-home for doing inquiry-oriented stuff like that. So for example, in a biology lab, they use their test kits, but they have lab kits which get sent to the students, but a lot of it is inquiry, test these 2 UV products, grow yeast, and then find out whether that UV sensitive yeast, how it responds to things, but design an experiment to learn something about testing the efficacy of these claims or something. And they're in the position where then they can actually test them with the experiment, but there's actually a real opportunity there because, maybe procedural labs aren't as appropriate in this setting. I've got Kevin. Do you have a thought on this same topic, or is it a new question?
No, it's the same topic.
Okay, I'm going to go to you and David, and then I've got a new question. Go ahead, Kevin.
Thank you. So I'm one of the instructors for the Chemical Engineering Unit Operations Lab. And so the way that Emmanuel, sorry, that wasn't Emmanuel, was just describing this,
Stefano.
Stefano, thank you. I see Emmanuel on my screen, sorry. So the way Stefano described it, that's actually how we do our labs normally. So the students do have to design them and then go implement the plan that they have for the lab over 2 lab periods. And in intervening time, they have to give a presentation on it. So when we had to go to the online this spring, we couldn't let them in the lab, but we still made them do that conceptual design. And then we replaced the part where they present the data that they would have otherwise acquired with the presentation of that design. It's considerably less satisfying than the actual class, but you absolutely can implement that. I mean, we have the documentation for how one could go about doing that we could share with people if they wanted.
Thank you, Kevin. I'll come to Dave and then
Yeah,
Kevin.
real quick, this is super short. It occurs to me that I think we'd be better off if we did those videos of taking data or making a measurement if it was live, right? So have the TA in the lab with some sort of a decent video camera doing what the consensus of 3 or 4 groups came up with for the design plan and walking them through what worked and what doesn't work. And even showing them I plugged it in wrong and it didn't work and I had to move the chip over and rewire it or whatever. I found that, yeah, the live element of showing TAs interacting with your circuits and your code in our cases has been the critical piece that we need to keep connected to the students, because they don't learn in a vacuum as well as they do with someone talking them through it.
Yeah, I think it's a very good idea, because there's an element of unpredictability that is a vital part of an experiment, and you want to recreate a little bit of those unknowns, although they're very controlled unknowns, especially with our machine that otherwise would break, right? But we cannot really experiment that much with the protocols, but some unpredictability is nice. And I think that because there aren't many students actually doing it, the whole thing would be faster, so you can use the extra time of the lab session to really accommodate those questions, those kind of back and forth, to make it lively. That's an interesting thought, yes.
Yeah, I like that too. I think something that I've, in working with folks in STEM disciplines, have found myself trying to reiterate is that so often students only see perfect solutions, right? So when you go to record the procedure, when you go to record it in the lab, you stop filming when you make the mistake and you plug it into the wrong place, or you quickly correct it without explaining to them how you knew it was wrong, or why, or what you're doing. You just quickly correct the mistake when in fact there's often learning moments there. And I think Dave is really nice, and Stefano are really nicely pointing out too that there is some possibility for keeping those learning moments in. And I think even if you were recording, leaving those in and explaining why, and I'll just give a shout out. I know Mike Mano, when he records his lecture videos, leaves in his mistakes on purpose for this exact reason. He's giving me like a huge head nod. I don't know if you want to say anything more about it, but mostly just he leaves them in and says, oh, and here's how I knew that mistake. So I think too, there's a model for that.
Yeah, it's completely, in my stuff, it's completely unpolished. And I think the students appreciate seeing that kind of authenticity of you doing that. So I think also showing in a lab setting, mistakes happening, I think is important as well too.
Okay, I'm going to go to Tanner, who's got a question.
Yeah, this is also related. Tanner Akin from Biomedical Engineering. I have not taught a lab course in spring in this semester, but next semester I will be teaching an electricity lab, pretty much. I think if the labs are closed for the worst case scenario, taking some of the workstations or lab stations to home or in the lab and then doing it with the students live, and then they watch it makes sense. I think that is a plan for me. But I think having a hands-on experience is very critical, and I like to provide that somehow. And then the kit idea is great, and I'm thinking if there's a budget or if there's a dollar amount that I can invest per student to buy such kits and send them, and some of those experiments at least they can do by themselves.
Yeah, I think the deadline's passed, but we recoup some of that cost through the lab fees, which are associated with the course. So maybe if you petition someone in the college, you could get your lab fees changed for next fall, if you need to.
I can definitely do that, but if the labs are open, then maybe that money will not be spent, if that's okay.
Or the students still keep the kits and they get to do parts of the experiments independently or with the pieces.
Okay. Is anybody, Imad, I think you said about the kits from EE. Maybe we can talk about do you about
Sure.
the prices and so?
Yeah, actually, David is, has been doing this for a number of years. So he has the same expertise or even more expertise in this. The kits are about $30 or so, if I'm not mistaken. So it's not a huge cost. Now, going forward, if we have the students add some simple oscilloscope function generator, it will be more like, so you think of it as a textbook, for example. It's still affordable. The students can take it, but I think it's a valid approach for labs like yours and ours. With regard to some of the discussion about live lecture and so on, so even in our situation, it was like just the only person who had a lab station available to him was myself. So I did the procedures, but what we did in the lab, the TAs played the videos and stopped at points where we said, okay, here, what do we do here? In fact, that was very successful. The students were still very engaged, very interactive, and that's what I was trying to highlight. So the idea of doing things with what we can, let's say in your own lab, in your case, with your instrumentation, the student can have something simpler, like a simple kit, and they can work on it. But those videos can be made very interactive. And I agree that doing it live would be better than not. In fact, one of the experiments was done live in our case, but unfortunately, I don't have 28 hours in the day, so I couldn't go to every section of the lab, so that we had to do it by video. But one way you can use the videos effectively is to instruct the TAs to stop at certain points, engage the students, and I can assure you that worked extremely well. I felt that the students were more engaged during these sessions than some of the live. I'm not exaggerating, and the TAs would support these observations. So I think it gives us a new opportunities, and we, going forward, will make them better. But adding a kit to your lab will be very helpful because it allows the students to do something at home that mimics what you would have made them do in the lab. I think that would help.
I'll come to Kyle.
Thanks.
Yeah.
Yeah, I was just going to add a quick comment on lab kits. I'm the administrative director for electrical computer engineering, and we provide lab kits for lots of our courses and are willing to help provide lab kits for courses in other departments of the CSC. We're set up to do that. We order a lot of parts at wholesale, we assemble them, and then are able to give them to students at a cost for quite a bit less than if you order them through an online bookstore type situation. So I put my information in the contact. If you want to talk further about it, we can try to arrange that and make that available for students. They can pay directly with Go for Gold, or we do our lab kit fees, which is a little more of a process, but might be emergency capable considering in the fall. So.
Yeah, and that's the way, so in, you guys are getting the benefit of being the last discussion I've done of these. I've done 4 others with other STEM versions of STEM folks. And some of the science labs do exactly this kind of thing. So they waive their lab fees when they have their labs online, and then instead have some form of a kit. In some cases, it's assembled by the unit and sent out in the way that Kyle's describing. In others, they use a third-party vendor who puts together the kit and then sends it out to the students. Some are using third-party vendors, which gets sent to the bookstore, and then the bookstore sends it to the students. And then in other cases, they put together a list of lab materials on Amazon and say, you need these lab materials. That's worked particularly well for a physics course. And then some students who are physically co-located can share kits because if you've got 2 roommates who are still living together and both taking physics, they can buy one set of the stuff and share it, because for the kinds of stuff that they're doing, it's not crucial that they're separate. So there's lots of different models for getting students stuff. The big deal to consider there is, the big thing that comes up there, particularly for the chemistry folks, I don't think many of you would be in this scenario, but in case you are, is considering hazardous materials. So anything that gets sent to them, that if you ask them to buy them, there's liability stuff. So you just want to make sure that you're either using a third party or checking with the DEHS about the materials. So Tanner, back to you.
Oh yeah, yeah. I mean, on that note, what you're saying is that the same station can be used by multiple people at different times. Is that really correct, or do we
Yeah,
need
that's what that
that
physics,
to
not the same.
disinfect the materials?
So they, oh, sorry, ask your.
I mean, it may require a level of disinfection and maybe.
Right. Yeah. I mean, in this scenario, it's kind of different, but the guy who'd been teaching a physics lab, Pete Border, for 10 years said that that often students in his class may know each other outside of the class. They may actually in person know each other, which will probably be some of the situations for your engineering students. And so what they would decide to do is that they'd take the lab kit and one person would buy it and then 3 would use it, run all their own experiments and submit their data, but they would save money. It's like sharing a textbook, kind of. It's the same kind of idea. Yeah. And then the other thing too,
this is James in aerospace. Of course, bear in mind that only works if you're willing to have everything be asynchronous.
Yes, that's correct. That is correct. Yeah, I'll go to you, Emmanuel.
Emad, you mentioned you have a combination of live and interaction. Will you be willing to share one video of your lab that you consider successful?
Yeah, actually multiple ones. I don't know if the TAs recorded their own sessions, but I have my recordings. And we can try, even though we're done with the lab, but I think it's a good idea to record one session as an example. I will ask for student volunteers. We'll try to do it for this group. If they're willing to work with us, we can do one lab session the way I described. The other thing that I should say, we have already received some reports and I'm waiting for the last report, which kind of puts everything together. So to me, that will be the ultimate judgment or the ultimate, measurement of whether we have been successful. To me, the quality of the report is what tells whether we have succeeded. And I am actually anticipating the last report will be high quality because we really enriched the student experience. But I will ask for student volunteers to run one lab session with them and maybe do the recording the way that we have described and give you an example of how that might work. We were really quite happy with the way the process unfolded.
Cool. I'll come to Tanner.
Yeah, related question. So I like the idea of stopping the video and talking about it. And but if you do it by yourself, then you want more people to watch you, so you don't have to repeat over and over too many times. So the question is that, can such a thing be done over the weekend, or will it be another question? Because normal time, you only have 20 to 40 people. My class is 90 people. We divide it into many sections. So they have other courses to take. So over the weekend, they can watch all together.
Oh no, what I've done is I recorded the procedures in one video that can be segmented like we mentioned, but the TAs in their session, they take that same video and share it with the students and kind of like stop at key points and ask for specifics. I had a document camera, thanks to Kyle. He acquired quite a few of these before we start. So it kind of has a nice projection of the circuits that I'm working on. And then my computer camera was at the oscilloscope screen. So everything that we were doing, and by the way, including mistakes, the students would see. And they have a clear view of everything that happens. But it's only one recording for all 4 lab sections in our case. But the TAs have the flexibility of using that recording, right, to share with their students. And what we added to it is in the last lab, like I said, we actually, instead of giving them like screenshots to make oscilloscope measurements, we gave them the raw data as well. And we benefited by getting the student to use MATLAB more, which is one of the objectives of the course that we did not do well in the fall. So to me, that's kind of the blessing of this new model is that we actually allowed ourselves, or found a way to give the students exposure to this important tool. As you know, MATLAB is very, very important, and we like to share with the students as early as we can. So this is the first time we actually get our students to use MATLAB at the sophomore level.
I'm going to have one note on kind of synchronous versus asynchronous elements. So this conversation is kind of circling around how much should we do live? When should we do that? And how much should be recorded? And I think for the current spring semester, doing a lot of synchronous made a lot of sense because students were used to coming to lab. They were used to the schedule. And I think people had less dispersal of folks across time zones. In my informal kind of conversations with folks at the U is, however, I just want to caution us that by fall, we may be in a different scenario whereby more folks may be at home in places where their internet isn't as stable, and they may be across more time zones as people return home or are stuck. For our international students who may be stuck, and depending on how the university chooses to do that. And then in addition, we're going to have an additional kind of wrinkle here as I think this pandemic passes through our community, and that more of our students are going to experience disruption from either being sick, caretaking, or the like. And so I think it may also be worthwhile to think about how can we have synchronous elements, but maybe have some of those be more optional. Or replaceable with something else. So if someone has to be out of the class for a week or two and can't log in, or their internet doesn't support the live, or it's broken up enough that you're not catching the complex terminology of our lab settings, that it's less disruptive for them. And so I just think it's something to consider as we kind of move into the next phase of this, of how much of that synchronous versus asynchronous elements do we want to have. And now I kind of want to finish off with the last topic of how are you having students submit work? And the reason I bring this up is because in some of the other lab discussions, one of the things that's been really interesting is people taking advantage more of video submissions of things, especially for those who are doing work at home. So maybe they show how the simulation worked, or maybe they show the lab setup that they've created with their kit at home, or other such things. So I was curious if any folks have been trying various kinds of submissions that are not our typical lab reports.
That sounds like a good idea. We have, no, seriously. I think we have relied on lab reports, but I agree with you that with someone who has a kit at home and so on, they can demonstrate that they have done it. And it does not have to be like immediately showing this, the TA, but recording that they have done or gone through the procedure. It can be done fairly reasonably because the procedure itself, if you're just trying to show that you know what you're doing, can be recorded fairly quickly, 15-minute segments and things. So I think that's a good idea. It did not occur to us to do this year. But part of it is because the student did not have the ability to make measurements with their kits. They only have the components for the most part. But going forward, when we give them the measurements, I think the video recording would be a great idea. I would be interested in implementing that idea. Yeah, and a lot of folks who are doing that are using FlipGrid, which is a tool which allows students to submit into it with time limited. You can set the limit on it up to 10 minutes, but you can say, no, you can submit no more than 3 minutes, which can be really nice for forcing concision. And I'm going to go to Dave and Tanner.
I was just going to go say real quick, the project submissions, we did do videos extensively. Short, very short, kind of like introduction. Here's my video. Here's it in action. This is its features. Okay, I'm done. 2 to 3 minutes, relatively quick, just to give them something to showcase and show off really more than anything. And the interactive stuff like checkoffs in lab, did you do the experiment right? We always make those interactive with questions prompted. The TA prompts the students with a question. And so those are done in Zoom sessions.
Any other, I want to take any questions folks want to throw out to this group?
I kind of talked a little bit, Chris, about the question I had. It's not particularly typical lab, but design labs, capstone design labs. I don't know if anybody has experience on how to deal with that kind of environment where you have projects, you're working with maybe a company, mostly companies, and you have teams of students, how you can engage the students to still be able to design and build a product, because this is no longer simulation. This, you have to, an example, you want to build a desktop for a person. You need to have a physical product. I don't know if this is something that you people have thought about doing in the Twin Cities area.
Do we have any of the capstone instructors? Otherwise, I've got a list of the 5 in the engineering, in the CSE departments.
So I supervised a design team.
Shannon, I see you.
Okay, it's okay. Go ahead.
I'm going to go to Shannon.
Oh, sorry. I was just going to say I was actually a TA for the BME senior design class the past 2 semesters. So it's a fall and spring combined class. And it was interesting because the students were so far along. They did a lot of their prototyping in the fall. And then usually they would do additional prototyping and testing of the design in the spring. But due to the kind of the last minute nature of all these changes, we ended up having them move their focus more to the business side. Like usually they have a testing and validation document and then a business plan document. And we ended up canceling the testing and validation just because it wasn't clear. These students aren't able to convene with their prototypes. They're not able to do kind of the in-person testing that they need to do. So at least for this semester, we switched it to just focus more on kind of the market and how you would get the device to the market. But moving forward and just design classes like that, where there's not a uniform kit that you can send out, how to handle things like that. I'd be interested to hear if anyone has ideas.
Yeah, Chris, Shannon. So like I said, I am working with a design team this semester where we had a very nice hardware components, a beautiful, public eye, just a nice, very exciting project. But unfortunately, because of what happened, we had to switch the focus of the design to more software architecture documentation instead of actually completing the project. So that was unfortunate. There was no way around it. But that's just for this semester. Going forward, one would think that even if the students are physically separated, a way to share the hardware or with the students, either by mail or if they're together, like you mentioned, some of them. So we have to do it this way for these capstone. There is no other way. I mean, we can find alternatives for in physical labs in the sophomore and maybe junior year. But I think the capstone, if it involves hardware, we have to provide the students with the hardware, no matter where they are. Hopefully, it's not something huge. Like in our case, it's a camera with a setup, but there is a hardware that they actually have to work with. Unfortunately, because of what happened, we had to kind of shift the focus of the design. And to me, that was not satisfying to us. And in fact, we had an outstanding group of students, and we feel that their effort was kind of somehow underutilized, but that's the adjustment we had to make. So
the thanks for your feedback. The challenge I am trying to see if there is a way to solve is in our own department, 100% of our projects, senior design projects, are with the industries. Yep. Locally in Duluth or in Twin Cities area, and they are usually a bulk of physical product. They are not, yep. So it's a challenge because we have, over the past 19 years I've been teaching, this is our trademark, building, yep. fulfilling design challenge projects for Air Force or for industry. And I don't know how we're gonna move forward, doing that, because that's where our students get the practical experience. They have to go to the plant, take measurements, come back, build, go back, implement. Now it's no longer gonna be possible. I don't know how we're gonna do that for spring or for fall semester.
Yeah. Well, I'm going to put you in contact with the others who are all coordinating those capstone. If there's anybody else at Duluth who's probably not on that list, I've got the list from Will Durfee of the folks who are all leading this spring, and I'll send out an email to get you in that loop, or I'll connect you and Will, and you guys can continue from there.
Okay, thanks.
Okay, as we close.
Can I make a comment, please?
Oh yeah, please.
So, Emmanuel, this is James. I don't actually teach aerospace capstone, although I'm sometimes involved as a mentor of certain projects, but you have time to plan. And I guess I would say when you approach companies, more or less just say, we don't yet know whether or not the students will be together in person on campus at all. And so please keep that in mind as you propose projects, or perhaps have a project that has different possibilities. Like, if the students are together, here's what it would look like. But if the students are not together, make sure you have a plan and the project doesn't fall flat. At least you have some months to plan for this. And frankly, you might end up having to reject some projects, or just tell them, look, that's a good project. We'll try and do it in the future. We can't do it under this current scenario.
That's great advice.
Just be very upfront with people.
That's a great idea. Thanks.
Any other thoughts for Emmanuel? Okay. So here's what I want to do. I want to do two things as we kind of close out our time together. One is I have this quick poll, which is just to kind of gauge some interest in having additional discussions with engineering lab folks this summer. Interest in a Google group or email listserv where you guys can share resources or send questions as you're developing labs, and particularly as the situation changes. And then, nope, I'm good and thanks for asking. And all of those are completely fine, and you can check more than one box. So I've actually already set up the Google group, so you can either just say no, yes or no, but I also will send all those invites as well. Okay. And then the last thing, I just put a link in the chat, is to a link to an eval to give feedback on how this session was. We've been, at the request of Provost Croson, leading a number of these sessions over the last 10 days. We've led them on everything from studio performance and dance to engineering to field experiences and all of those kinds of things around experiential learning. And so we would love to know how we've been doing as well. And I will just say that on a personal note, it's really great to hear about the creative problem solving. I find that engineers often rise to these challenges so very well, right? We just change the constraints and come up with a new design. And I think that that's kind of the attitude we may need to take with this. And some of those will be great and some of those we'll be disappointed with, right? And we'll just kind of keep learning from the experience. I think I once had a civil engineer tell me the whole point is continuous, what is it? Incremental continuous improvement.
Continuous improvement.
Continuous improvement, right, is what everything is about in engineering. And so I really appreciate you taking that opportunity. And as a person who's been working with you around teaching and learning, it's been really impressive and inspiring to watch as well. So please feel free to reach out to CEI or other elements of teaching support at umn.edu. And we'd be more than happy to help you. So thanks a lot for joining today, and hopefully we'll be in touch soon.
Thank you very much.
Thank you.
Thanks, Chris.
Bye.
Thank you.
Yeah, bye-bye.